Okay, on Thursday, you're going to have the quiz, okay, the unit quiz on Thursday. Basically, think of it this way. Easiest way for me to put it, take all the pop quizzes, put them into one. Pythagorean theorem, what we did yesterday, and then SOHCAHTOA, what we're doing today. All right, so that basically sums up your quiz. All three pop quizzes, Pythag, and then sine, cosine, tangent. Okay, it's a tough year here for me because this stuff I'm showing you today, sine, cosine, tangent, was done in 10th grade, but you guys know how your 10th grade year went. All right, you know how that went. All right, with us getting out of school in March and not coming back. So please be upfront here with me. Is this something that we did, sine, cosine, tangent?
I believe so.
Okay, because this is where I start feeling bad and growing a heart, and that is, this is something probably in geometry you should have done like 4 or 5 days with, and I'm about to do it in 25 minutes, okay, to review with you. So at any point, stop, ask as many questions as you need, because I can't do another day and another day and another day of it. This is it. All right, and why am I doing this? Because after we take the quiz, you got to know how to find sine, cosine, and tangent pretty quickly. All right, with the new stuff I need to show you after the quiz. So first, sine, cosine, tangent, it's got to be in a right triangle, okay? Sine, cosine, tangent, to be able to use it, just like Pythag yesterday, you got to be able to in a right triangle. Got to be. All right, so how do I use this SOHCAHTOA business? All right, let me start with the first part of SOHCAHTOA, which is SOH. All right, what it all stands for and when do I use it? The S in SOHCAHTOA stands for sine. Everyone, if you haven't seen it on your calculator, you got a sine button there. It's abbreviated SIN, but it's actually spelled SINE. Okay, so that's sine. When in a problem would I want to use sine? That's where the O and the H comes in. Anybody remember what the O stood for? Okay, that's fine. Opposite. That means I know something about the opposite side in my triangle. And we're going to do plenty of these today. The opposite side. What do you think the H stands for? Hypotenuse, yes. So I'm going to use sine in a problem when I know what the opposite side is and the hypotenuse in a right triangle. Hypotenuse. Okay, so that's when I'm going to use the sine key. All right, next up, C. Anybody C? That stands for cosine. C, it's abbreviated COS, but it's spelled COSINE. Cosine. When is it appropriate to use cosine in a problem? Ready? When you are given A, which is going to stand for? Adjacent. All right, good. Adjacent. We remember a little something. When you're given the adjacent and the, I'm going to stop writing now. H, hypotenuse, correct. I'll use cosine. All right, there's one pair that I have not discussed, and that is for T for tangent. Yep, this is T for tangent, abbreviated TAN on your calculator. And when would I have to use the tangent? When I have, ready, OA. O for opposite and A for adjacent. There you go. All right. Again, stop me at any time here. This is just a device to remember when to use sine, cosine, and tangent. It's just a device. All right, I'm going to skip to part B first because I want to do part B and C, then I'll go back to part A. All right, so everyone see my right triangle up here. I got 5, radical 75, and 10. Find tangent of A. So first of all, that tells me what angle we're all looking at right now. We're looking at angle A. Go back to SOHCAHTOA. What is tangent paired with? SOHCAHTOA. What is tangent paired with? O and A, right? So that tells you if you want to find tangent, you better take the opposite side of A and divide it by the adjacent side of A. That's how I use it. It's opposite over adjacent. So look at angle A right now. Look at angle A. Can you tell me what the opposite side of angle A is? 5. Can we all agree there? Because sometimes kids do have problems finding the opposite. Everyone all right? Opposite is 5 over. Now adjacent means next to, and it can't be the hypotenuse. Okay, because I know you're at A and you're like, well, radical 75 is adjacent, so is 10, right? But 10 is across from the right angle, which makes it the hypotenuse. So what's my adjacent side? Square root of 75. Okay, this is where I take it a little bit above a regular class and bring it up to a senior level. Simplest radical form. I discussed with you guys yesterday, no radicals in the denominator. How did we get rid of them? You guys that were here yesterday, how did I get that one radical out? Nora, got something?
Both the top and bottom by the radical.
Multiply top and bottom by the radical I'm trying to get rid of, which is radical 75. Good. All right, so anybody want to keep helping me here? On top, what do you end up with? 5 and radical 75. I can't do much there. And then this is why I do that. Radical 75 times itself. Number underneath, remember. And it's okay if you don't remember that. Use your calculator. Radical 75 times radical 75, and it'll give you a 75 back. I do want you to take it one more step. You cannot cross out the 75s. Absolutely not. One's underneath the radical. But what can I still do? 5 over 75. Yep. 5 into 75 goes how many times?
15.
So I got radical 75 on top, over 15 on the bottom. You cannot divide those. And honestly, that, yes, I could do something with radical 75, but I'm good now. I don't want to press my luck. All right, you guys got enough going on with all this stuff. I'm good right there. Regents time, we'll worry about that. But for me right now, that's fine. That's reduced as much as I need it to be. So we picked O over A. We're good. Yep, go ahead, Hans.
So how'd you find the 5 again? Like, how'd you know that was
Okay.
opposite?
Tangent of what angle?
A.
A. So I looked at angle A on the triangle. What was opposite? The side opposite angle A was what? 5. Over the adjacent side to angle A.
Okay. So-
Radical 75.
And adjacent just means next to it.
Next, not the hypotenuse, but next to, yes. Okay, hypotenuse is always hypotenuse. That's H. Lumi.
Do you have to leave it in like a fraction form, or can you just put like 15 radical 75 next to each other?
15 radical 75? That's not the same as what we have here. This right here is 15 times radical 75.
Oh, I see.
Okay? So I need it left like this. Anything else? All right, let's keep going to C now. Cosine, new right triangle, cosine of A. Cosine of A. What's that fraction? Cosine of A. So everyone go back to SOHCAHTOA. Cosine is what side over what side? Adjacent over hypotenuse. And what angle am I looking at? Angle A. By the way, just to put this in your mind, you'll never look at the right angle. Okay? Never look at the right angle. It's one of the other two. All right, so let's look at A. What's adjacent to angle A? Radical 72 over the hypotenuse in this triangle, which is 9. It's always hypotenuse, always across from the right angle, no matter where we're looking. And is there a radical in the denominator? Can I divide the 72 and 9? Okay, so I'm going to just leave it like that. Okay, I know we can break down 72, but we're good right now. We're good. All right, what about sine of A now? Okay, now go to SOHCAHTOA. Now what two sides? Opposite side and hypotenuse. Good. What's opposite A? Are we okay on that? Because sometimes kids get worried with the opposite part. 3. And we just said the hypotenuse was what? 9. 9. And yeah, I would ask you to go a little further, especially in this course. 1/3. All right. Yep.
Is the hypotenuse, so it's always like above the
Across
angle?
from the right angle is always the hypotenuse.
Across from the right.
Always H. Yep. Always. Okay. We okay? Because now I'm going to show you how to use this to find a missing side in a triangle now. Okay, how to find using sine, cosine, tangent, how to find a missing side. So let's go back up to A. Can you guys please draw me that diagram? That would be great. You guys do that work for me. Draw that diagram. Triangle ABC with right angle C. We did this yesterday. Plug in 37 degrees for angle A and put a 20 on side AC. A nice right triangle going. Yep, Elliot.
Is it always gonna be the same, like A is in the bottom corner, B is on top of the
It doesn't matter.
Okay.
As long as you, well, it does matter that you put C as the right angle, but A and B will not matter. But that's still going to make the hypotenuse, so that's not going to matter. And again, just like I told Elliot, your A and B could be flip-flopped to mine. It's not going to affect the problem. We're still going to use the same sine, cosine, or tangent. Yes, Molly.
If it's not one of the special triangles, are all the angles supposed to add up to a certain number?
What do you mean?
Or all the, it's like it's supposed to be 90, 37, and like, is it to find the third angle? Are they all
Don't find the third angle. You're just going to be more confusing. Okay. All right, so I have a couple questions for you guys before we start. We did all this work yesterday with Pythagorean theorem. Why am I just not using Pythag? Talk to me here. Why am I have to bust out this sine, cosine, tangent business? Why isn't Pythag good enough from yesterday?
Same two sidelines.
I have what? 20 squared plus, oh boy, I don't know anything about BC, right? I don't want to introduce a new variable. So you see, I don't have enough information for Pythagorean theorem. Okay, is this a 45, 45, 90 like from yesterday? No, how about 30, 60? Okay, so I'm just trying to prove to you guys nothing that I showed you would work here yesterday. This is why I need sine, cosine, tangent. All right, first job, figure out which one of the three I need, sine, cosine, or tangent. What's the angle I gave you? A, which is 37. Everyone, you always focus on that angle. All right, the non-right angle that it's given, 37. What's X in this diagram? You got three choices, opposite, hypotenuse, or is it adjacent? It's the hypotenuse. So here's what I'm going to do, and I recommend you do until you get very, very good at this. I'm just going to put a little H next to it in parentheses that tells me you have the hypotenuse. What's the 20? And remember, you're looking at 37 degrees right now. So is the 20 opposite or adjacent to the 37? It's going to be adjacent. Everyone okay? It's adjacent next to. So I'm going to put a little A next to it. Now, if you look at SOHCAHTOA, what's the only one out of the three that uses adjacent and hypotenuse?
Cosine.
Cosine. So we just found the one we need to use in this problem to find that side. Are we okay? So we got to use cosine. So now we're going to build our equation to solve. Cosine, abbreviated COS. And we always put the angle with it. Cosine of, what was the angle I'm using? 30. Well, now instead of A, actually the degree measure. 37, and this is why your calculator's in degree mode. Equals, what's cosine equal to again? A, which we labeled as what? 20 over H, hypotenuse, X. That's how I build the equation. Adjacent over hypotenuse. Now, how do I solve it? Look, I'll make this easy for you. No choices. Just put this bad boy over 1 and cross multiply. Ready? 20 times 1, 20. And on the other side, cosine of 37 times, what am I cross multiplying it with? Okay, you guys know you got to solve for X. So you're good enough at this. What do you think I have to do to get X by itself? Divide by what? Cosine 37. Good. So I'm going to divide everything by cosine 37. And this is where your calculator comes. I don't know what's going on. I'm sorry. Cosine 37. Now you go to your calculator. 20 divided by cosine 37. You can put it in a fraction template if you prefer. And that'll give me side X. And I do have rounding directions, right? Yep, nearest tenth. what was this, 20 something?
25.
25.0. Yes, Libby.
What's the like arrow next to 5?
Where I know it's getting, I don't know, my board's acting up here. Where are you looking here?
Oh, above the cosine 37, like 37, and then in parentheses x. Yeah.
Here?
Yeah.
Right here?
Oh, I think that's.
Oh, it's
It
a
just
COS.
says-
Okay.
All right. Yeah, I don't know what's going on with my board here. It's doing its own thing. Must be user. 25.0. Are we okay with that going? We sure? All right, you know one doesn't make you great, right? There we go. And again, I am sorry, but in another way, I'm not. Just this would be like a 4-day topic in 10th grade. Okay, we got a shadow problem here. 10-foot lamppost. Yep. We got a new vocabulary term I got to talk about. What's that right there? It's 58. What's the length of the shadow? All right, so just draw, you know it's going to be a right triangle problem. So let's draw yourself a right triangle and let's figure out where do I put these things. 10-foot lamppost, what do you think? Left, bottom, top, hypotenuse. Okay, good, thank you. 10-foot lamppost, perfect. All right, angle of elevation. I'm sure you don't remember this at all. Angle of elevation is inside the elevate. You're looking up, right? So that's what's happening. You're on the ground looking up at an object. So this angle of elevation is located right here in the triangle. All right, elevate, looking up towards something higher than you. So that's where my 58 is going to go. Angle of elevation, bottom up. And I always get a little chuckle out of this one. You're finding the shadow length. Pretend you're outside on a nice sunny day and you see your shadow. Okay? We have one of two places right now. Is your shadow on the ground or is it beaming off your forehead? Where's the shadow on a nice sunny day? On the ground, right? You'd be a freak show if it was coming off your forehead. We all agree? You'd be defying physics. Yes. So that is what we were looking for right there. Your shadow is on the ground. Okay, let's figure out. Pythag's not going to work. Don't have enough information. So I go from 58 degrees and I figure out what's the 10 feet and what's the x. Hypotenuse, opposite, and adjacent. That's what I got to figure out. So what do we think about the 10?
Opposite.
It is opposite the 58. And the shadow we need to find on the bottom? Is it? Yeah, just asking. Make you think a little bit. Because look, we always know the hypotenuse is across from the right angle. Don't even label it if it's not there. All right, so O and A, go back to SOHCAHTOA. If you have the opposite and adjacent side, we're going to need what for my equation? Sine, cosine, or tangent? Tangent, abbreviated TAN when I write it in the equation. What's the angle I'm using? 58. We're going to get better at this now. It's our second one. Tangent of 58 equals opposite over adjacent. Remember, go back to TOA. T-O-A. O-A. And what did we label opposite? 10 over x. Same thing. You want to solve it? Put it in a proportion and cross multiply this bad boy. So I got 10 equals tangent of 58 times x. What do you want to do to solve for x? Excuse me. Yep. Divide by tan of 58. And this is what your calculator's for. That's why I asked you to put it in degree mode, because the 58's in degrees. And no, I will not have you do these problems in radians. Don't worry. We'll stick to degrees. Thank you. So everybody can have a calculator now. AAA batteries. The calculators that I have that take batteries. What do we got here?
6.2.
6.2? All right. I believe you. I don't have my answer key on me, so. 6.2, we good? I'm going to try to get one more in here. And it's not going to be E. It's going to be F. So these last two problems, we found the side of the triangle, right? We found a side. What happens now if I'm missing the angle? You know the sides, but I'm missing the angle now. All right, so real quick here, because I'm running out of time. We got a 20-foot pole leaning against a wall. Where's the 20 going to go? Hypotenuse, right? It's leaning against the wall, just like your ladder was yesterday. 20, and it reaches a point that is 18 feet above the ground. So where's my 18 feet above the ground? On the left, good. So I'm going to ask you guys to help me out. Find to the nearest degree of the angle the pole makes with the ground. Does everyone see the angle I'm looking for? The pole makes with the ground? Top or bottom? Bottom, okay. This is the first time now we needed to find an angle, right? I'm not going to change the rules. What's the 18 and what's the 20? You guys know what the angle is. It's the one we're trying to find. So what's the 18? That is opposite. I'm not changing the rules here. And what's the 20? That's my hypotenuse. So if you look at the three choices, sine, cosine, tangent, which one uses O and H? Good job. All right, ready? I'm still going to make up the equation the same. Ready? Sine, abbreviated SIN. What's my angle? That's right. I don't know. So I'm going to put X. I'm going to find it. Equals. Great. Opposite over. Hypotenuse. Watch your mouth. Okay, here's where I'm going to change the rule. When you find an angle, you do not cross multiply. We're not going to be able to. Instead, everyone look on your calculator. Do you see how you have a sine to the -1 button right above the sine button? That's what we're going to do. We're going to go second sine, which is called inverse. Inverse sine, and we're going to plug in that 18 over 20. That's what I do only when finding an angle. Okay, only finding an angle, I'm going to do the inverse button. Do not cross multiply when finding an angle. And what do we end up with? Second sine, 18 over 20. What do you have? About, what's the nearest degree?
64 degrees.
64 degrees. There you go. So that's the only change up for when I find an angle. Okay, we will review as much as we can tomorrow. Get ready for Thursday. Good work today. Solid session. If you need any help, you guys know where I am.